Hello everyone, welcome to Docker Community All Hands 5. This year it's Docker's 9th birthday, so happy birthday Docker, and thanks for giving me this opportunity to speak at this event. Today I'm going to talk about machine learning with TensorFlow Object Detection running on a Docker container. A little bit about me, my name is Madhu Kumar Yeluri. I'm a principal cloud architect working for T-Systems International based in Budapest, Hungary. I spent a little over 21 years in IT, working for various sectors, telecom, financial, banking, insurance, retail, and government. For the past few years, my focus is on cloud migration, cloud adoption, containerization, and security, helping many customers transform their business and scale on cloud. I also organize community events as part of AWS Community Builder, Docker community, and DevSecOn community. So feel free to add me, follow me on LinkedIn. So what's the agenda for today? So I'm going to mention a few surprising facts about Docker adoption in general. What's TensorFlow? We're going to create a Dockerfile, install TensorFlow, Jupyter Notebook, and we build it, we run the Docker image, and basically we see the object detection for 2 sample images. And we conclude, and I'll take any questions you might have. Surprising facts about Docker adoption. So this is done by basically Datadog, monitoring platform. So basically the survey results are nearly 1/4 of companies have adopted Docker. Docker now runs on more than 20% of the hosts. Docker usage increases with infrastructure size. Half of the Docker environments are orchestrated. The average size of the Docker deployment has grown 75% in 1 year. And most commonly used Docker images are Nginx, Redis, and Postgres, MongoDB, and a few others. The median Docker organization runs 8 containers per host. Orchestrated containers churn 12 times faster, so no surprise there. So companies are adopting microservices architecture, containerization to basically leverage the cloud adoption. So what's TensorFlow? So TensorFlow is a free open source software library for machine learning and artificial intelligence. It's used across a range of tasks for model training, deep learning, and yeah, so it's initially developed by Google for their internal research, and they made it generally available. So we're gonna create a Dockerfile. We run some Python libraries. We install TensorFlow. We install Jupyter and supported libraries. We install some TensorFlow models, and we basically test sample images if it can detect what they are. I will go in a detail in demo, so I'll just quickly move on. So this is how it looks when you build a Docker image and you run it, and then basically we do finally we try to see the results of the object detection. So now I'll just move to demo. So here we have a Dockerfile. This basically do the same thing which I just mentioned. So we run some Python libraries. We install some Python libraries. We install TensorFlow and Jupyter Notebook. We log into the notebook once we build the image, and basically we test the images. So this is how it looks like on Dockerfile. Let's build the Dockerfile. So there you go. So we build the file, and we're going to name the file, name the Docker image, and where is my Dockerfile in the current directory. So what happens is it basically reads the Dockerfile layer by layer, and it builds the image. It takes around 20 minutes or so. So for just sake of time, I just skip that bit. And once you have this, we can just check where's the image. So it's basically Docker images, and I want to grab TensorFlow. That's the name of my image. So the first one, Dockerflow, TensorFlow latest, that's the image which we built. And now I would like to run the image. So basically run the image. That's the minus my dash rm is it basically removes the container when you stop it. That's the name of my container, mapping the ports to the host and the container for rates, and what image basically I would like to run, TensorFlow. So what it does, it basically runs the Jupyter Notebook locally, but in a Docker container, obviously. So as you can see, it's successfully running. I would like to see if it is running by grabbing Docker PS TensorFlow. So as you can see, there you go. So my Jupyter Notebook is running in a Docker container on this port. So now I would like to access that port and see if we can log in to the Jupyter Notebook, and then we'll do some object identification as well. So here we go. So it would be localhost :48. So that's the Jupyter Notebook. As you can see, I would enter my password. There you go. So everything you see here is basically running on a Docker container. So what we're going to do, we're going to upload a sample object detection tutorial, which I downloaded yesterday. So there you go. We're going to upload that. We open the tutorial. So here we go. So this is basically a Python code which detects the images, and then basically it identifies what those are as well. So here what I'm going to do, I'm going to do run all. So basically it starts from here and it executes step by step, and let's see what happens. So as soon as you see the stick one stopped, that means it's stopped somewhere. Alright, so TF slim module is missing. That's fine. So let's go to the terminal. Right, so let's install tf_slim. So that's one of the modules required. It requires for this object detection. So there you go. We installed it. So now let's go back and just say restart and run all. So it basically starts from the beginning again, and that's the user warning. That's okay, we can ignore that. And let's see. I think it needs some dependency there. So 1 second, let me update that. It basically needs to import TensorFlow compact, and we suppress the warning. So let me stop and restart and clear out the outputs. So we go here. What I did is basically I'm importing this set TensorFlow compact and then disable it. Only warnings. So now I go restart and run all. So this triggers the flow again. So that's the warning, so it's okay, you can ignore that. So it's here. Yeah, so basically at the end of the execution, it basically should detect the objects in the two sample images which I supplied, which I'm going to show you, and then it identifies what they are. So let's wait. So you can see that, yeah, there you go. It was successful. So as you can see, there's pictures, and it can clearly see it detected as a dog. And if you scroll down a little bit, you can see that some people standing on the beach. So it's detected as a person and a few other objects. So this is done um, by this Python code on top, and it detected all the objects what's in the picture. So just to make sure you know where those pictures are, test images. So here we go. So this one image, as you can see, it's not detected. It's just a plain simple JPEG file. And another one. So that's again a plain simple JPEG file with strings. So what happened is basically it pick up those frequency. It understands what they are. You basically need to train it, and yeah, so it detects what those pictures are and what it contains. Basically, so it's a dog, person, and some objects here. Sorry, it's hard to see clearly, but yeah, and yeah, so that concludes my demo actually. So we used TensorFlow and Jupyter Notebook. We got some sample images which we basically used to object detection, and we succeeded in doing so. And yeah, so and the whole thing is happening on in a container. So yeah, so that concludes my demo on object detection, but I would like to show you how to clean up. So once everything is done, so the easy way you clean up is basically you remove the running container by docker rm minus f and the name of the container, and then it basically stops the container and it removes the container. So every work or everything we install and we execute it, we run, everything is inside the container. So there's nothing that I have to install on my host machine apart from Docker engine to run it. But otherwise, everything is in the Docker container. So yeah, so that's how basically you remove. So I would like to go back to the presentation. So that's how you stop and remove. And why Docker? So Docker is my favorite containerization platform for obvious reasons. Yeah, it's a secure. It isolates your system resources and package it nicely with your dependencies and libraries that are required for your application. And yeah, run in a small bubble, and it's highly secure. I wrote some blogs on container security. Feel free to check them out on container security. I'm on Medium and dev.to as well. And why TensorFlow? So TensorFlow supports various platforms for deploying ML models on desktop, mobile web, and cloud. And these models are not restricted to one programming language like Python. They can also be in JavaScript, Swift, and yeah, it supports. And when the survey done by Stack Overflow, 65% of the respondents who are like developers, they like to use TensorFlow for develop models. And yeah, so that's TensorFlow. So I'm glad to the demo went well, and I'll take any questions you might have later, and I'm happy to answer them. There are a lot of exciting demos going on today, so I would like encourage you to follow, and please yeah, please go through them and have a rest of the day. and speak to you soon on a next event.